So the most important thing to review is to make sure that when you read the context of a real AP question that you can identify the procedure that's being used and then write appropriate hypotheses. So if you read this context carefully, this is about an experiment. So we're testing the effectiveness of a new procedure in order to complete ACL surgery. So we have 210 patients needing surgery. They were randomly assigned to either receive the standard procedure or the new procedure. So because we have random assignment to treatment and control groups, if you will, this is a two-sample situation, and because we are looking at recovery time, in fact, it even says mean recovery time, so this is going to be a two-sample t-test, and the reason we need to use a test is because a direction has been specified. So do the data provide convincing statistical evidence, there's the word why we should use a test, that those who receive the new procedure will have less recovery time from surgery on average than those who receive the standard procedure. So when you write the hypotheses, you need to use mu for mean, and these subscripts are what I'm using to identify the order. So this is the mean recovery time for the new procedure minus the mean recovery time for the standard procedure. So the null hypothesis would be that that difference is 0. So we're looking for evidence that the new procedure has less recovery time. So we're expecting the mean for the new procedure to be lower than the mean for the standard procedure in the population. At least that's what we're looking for evidence of. So if this first mean is lower, this difference is going to be negative. So this should be specified with a less than alternative. If you reverse the order of these population parameters in the null and the alternative hypothesis, that would be fine. You would just use a greater than alternative instead. Question number 2. This is actually a question that we did in the previous unit. So this is an example of a matched pairs t-test. And the reason being, for each car model, we have two observations, the amount that women paid for that model and the amount that a man paid for that model. So what we're really looking at is the difference between the prices paid. But those prices paid by women and men, those are not independent of one another. We don't have two independent random samples here because the truth is those prices are based on the same car model, so they can't be independent of one another. So this really is a one sample situation, a paired situation where I'm looking at pairs of observations for each car model. And in particular, you can see that you're given the dot plot for differences here. We're looking for evidence then, so this should be a test, that on average women pay more than men. So we should be looking at the average difference. This is a matched pairs t-test. So the null hypothesis is that the average, and look, I just used a subscript based on what they used in the real FRQ. So the average woman minus man, if in fact there is no difference for the population parameter, that average would be 0. So we're looking for evidence then that on average women pay more. So we're looking for, on average, that the differences between men and women have in the population, an average that's a positive. That would suggest that women are paying more than men. So for question number 3, this is a two-proportion z-test. So again, do the data provide convincing statistical evidence? So evidence rather suggests we should be using a test that there has been an increase in the proportion of all of these plants that are resistant to this particular herbicide. So notice we have randomly selected plants in 2014. We also have randomly selected plants in 2017. So we have a two-sample situation, and they are proportions because, well, frankly, it says proportion right there. So this has to be a two-proportion z-test. So to write the hypotheses then, the null hypothesis would be that there is no difference in resistance between 2014 and 2017. So when I wrote my parameter, I used a subscript of resistance 2014 and then the proportion that are resistant in 2017. So I took a difference between those. That difference would be 0 in the null hypothesis. So notice we're looking for evidence of an increase in the proportion of plants that are resistant. So an increase from 2014 to 2017. An increase would mean that the proportion of resistance in 2014 is lower and the proportion of resistance in 2017 is higher. So if this second proportion is higher, we would be looking for evidence of a negative difference between these two parameters. So this should be specified as a less than alternative. Of course, again, if you switch the orders of the parameters, so if 2017 was first and the proportion from 2014 was second, that would be fine. If you use a different order for both the null, if you have a different order specified, the orders have to be the same though in the null and alternative hypothesis. So if you did 2017 minus the proportion in 2014, it would be fine to use a greater than alternative. What's important is that you use the same order in both your null and your alternative hypotheses. So the last question, do the data provide convincing evidence that the mean length, well, so it's telling you that it's about a mean, so this has to be involve t-scores, of adult fish of the species from fish friends is greater. Well, now I know it has to be a test because I have a direction specified, and frankly, I knew it was going to be a test because of the word evidence, greater than the mean length of the adult fish of the same species from by right. Well, and if you go to the stem of the question up at the top, you know that you have two random samples. One of those random samples comes from by right, and one of those random samples comes from fish friends. So I know there are two independent random samples, independent in that they're from two different stores. So this is a two sample situation. I know that it's a test because I'm looking for evidence, and it has a direction, and I know it's about means because it's quantitative data, but it also says means. So this is a two sample t-test. So the null hypothesis would be that the mean fish friends length, so it's important that you use some kind of a subscript, some type of a way so that you're identifying which parameter is which when you write the hypotheses. So this is the mean length from fish friends minus the true mean length from by right for this species, so that difference would be 0. So I'm looking for evidence that the mean length from fish friends is greater. So the way that I wrote these, the order in which I wrote these, the mean from fish friends minus the mean length from by right, if I'm looking for evidence that the population mean is greater from fish friends, this would be the larger mean, this would be the smaller mean, so I'm looking for evidence of a difference that's greater than 0. Again, like I've said before, if you change the order in the null and the alternative hypothesis, now they have to match, so if you did by right length minus the mean of fish friends length, by right length mean minus the mean from fish friends, if you were consistent and changed that order, that would be fine if fish friends were second. If it's larger, then you would end up with a difference that's negative and you would use a less than alternative.